Integration by parts. In the previous section, we looked at various techniques of integration. Excuse me. But as you go through, you notice that it is possible to have an integrand whereby you know nothing of. There may be other ways of solving that we probably have not considered. And so in this chapter, we will consider new methods to being able to solve integrals, some difficult. Well, we start here with integration by parts. And what this simply means is that if you have an integral where the integrand has two components that are said to be mutually exclusive, they have nothing in common, the u and the dv. And so what did you do? Well, we can use this very neat method called integration by parts, and the result is just a formula that the integral of u dv is equal to uv minus the integral of v du. So you identify u and you identify u and dv, and then from u you need to be able to find its derivative du, and from dv you need to be able to integrate it to get v. So you identify u and dv, and then you do two things. You find the derivative of u, and you find the integral for dv. Now, I want to note here that there's a shortcut method to integration by parts, and it's called the tabular method. Only use the tabular method if one of the terms goes to 0 by repeated derivatives, like if you have in the integral x cubed, which would yield 0 at the fourth derivative. We can use the tabular method, and I'll go over that. And quite frequently, if we can, we want to always choose that. Now, sometimes you can't. Let's take this first problem. The first problem, I will use the tabular method. Again, it's the shortcut, which says here we identify the term that we will take the derivative upon, which is x. X will go out with derivatives, with the repeated use of taking the derivative. So here we deal with the x term, and then over here we look at the other part, which is the dv. So here we're letting u equal to x, and dv is equal to e to the negative 4x dx. So I put dv here, and this is e to the negative 4x. So the derivative of x is 1, the derivative of 1 is 0. You're going to alternate these signs, so it's plus, minus, plus. Integrate e to the negative 4x dx. Well, the integral of that, you have to use a u du, and the integral of that would be negative 1/4 times e to the negative 4x. Each integral would be a factor of negative 1/4. So this is negative 1/4 times negative 1/4. That's 1 over 16 times e to the negative 4x. The multiplication is on the alternation. So, and the reason why you pick one part to go to 0, the derivative to go to 0, because once you multiply 0 times this term here, then everything after that is 0. But the connection here would be the answer. So this is x times negative 1 over 4 times e to the negative 4x. So we can just say this is negative x over 4 times e to the negative 4x. And then here, this is negative 1 over 16 times e to the negative 4x plus a constant. I tell you, this left hand is so weird. You can't see half the stuff that I'm writing because my left hand is in the way. Again, the tabular method, because x to the cube will go out. So this is x to the third. Take its derivative, we get 3x squared. Its derivative is 6x. Its derivative is 6, and then 0. Alternate the signs. And then we integrate the e to the x. Well, e to the x, the integral of that is e to the x. So that repeats. Make the connections, and you get the answer. X to the third times e to the x minus 3x squared times e to the x plus 6x times e to the x minus 6 times e to the x. And don't forget your constant. Now for this problem, we cannot use the tabular method. You would say, or you can let u equal to t, and then you get the derivative, you get 1, the next derivative, you get 0. The problem is the integral of the natural log of t plus 1 dt. That's the only thing. Now you could do it, and it does work, but then when you have to integrate the natural log of t plus 1 dt, you have to do integration by parts on that. And so that takes a minute. So here, we'll just use the integration by parts principle. It says that the integral of u dv is said to be u times v minus the integral of v du. So here, let u equal to the natural log of t plus 1, and dv is equal to the t dt. So when I take the derivative of u, we get du is 1 over t plus 1, and v, you integrate this t dt, and that gives us 1/2 t squared. So using the form, this becomes u times v. So this is 1/2 t squared times the natural log. So this is 1/2 t squared times the natural log of t plus 1 minus the integral of v du. So this is 1/2 t squared over t plus 1 dt. I write it down here. So this is 1/2 t squared times the natural log of t plus 1 minus 1/2 times the integral of t squared over t plus 1 dt. Now on this part, it's improper. We have improper fraction we have to divide. So either you do this, or you let u equal to t and the dv equal to the natural log of t plus 1, and let me tell you, you get a lot of stuff, buddy. So t plus 1 divided into t squared, which is easy. This is t get t squared plus t. Draw a line, subtract, we get negative t. So this is t minus t over t plus 1. Now you look at that this term here is improper. So we have to divide. But it's okay. So we divide t plus 1 into t. T goes into t one time. 1 times t is t. 1 times 1 is 1. Draw a line, subtract. So we get 1 minus 1 over t plus 1. So if you go and start, from the problem, how we began, this is 1/2 t squared times the natural log of t plus 1. Then it was minus 1/2 times the integral, right, of t minus t over t plus 1. But the t over t plus 1 became this term. So this is t minus t over t plus 1, which is 1 minus 1 over t plus 1 dt. So now we integrate here, everything else just comes down. So 1/2 t squared, the natural log of t plus 1, minus, let's simplify all of that, 1/2 times the integral of t minus 1 plus 1 over t plus 1 dt. So now we can integrate. So it's 1/2 t squared, natural log of t plus 1 minus 1/2, the integral of t is t squared over 2, so this is minus 1/4 times t squared. This is minus 1/2. The integral of -1 is minus t, so this is minus a minus is positive 1/2 t minus the 1/2 times the integral of 1 over t plus 1, that's the natural log. Of the absolute value of t plus 1 plus the constant c. All around the world on the same song. Let's see what else we got. Well, let me take a bit of my Snicker bar before I turn into a very mean football coach, right? It's been an interesting day. That's nasty. It's not good. Okay. Sorry, I'm eating and trying to explain this. It's not good either. Water is good. Good and bad. Still gives you bad. Okay. For this problem, you don't even need integration by parts. Because think about it. This is a U du substitution. Because if u is the natural log of x, du is 1 over x dx. Let's write it. Let u equal to the natural log of x. So du is, take the derivative of that, we get 1 over x dx. So this integral of the natural log of x to be squared over x dx is equal to the integral of u squared du. Du picks up the 1 over x dx, right? It's du. And then the u squared is the natural log of x squared. So we just integrate that. So this is u to the third over 3 plus the constant. And u is the natural log of x. Well, not u, but u. It's natural log of x cubed over 3 plus c. Here, again, I believe we can work this by using u-du substitution as well. So let u equal to the x minus 5. Why choose x minus 5? Because this implies two things, that u plus 5 will pick up the x that's out here, and du and du is dx. So the dx is represented by the du. The u plus 5 will represent the x. So the integral of the x is u plus 5. And the square root of x minus 5 is the square root of u. We can just write that as u to the 1/2 du. Simplify. This is u. The integral of u times u to the 1/2 is u to the 3/2 plus 5 times u to the 1/2 du. These are all in a bag. I call it sin. So now we integrate here. So this is u to the 5/2 all over 5/2 plus 5 times u to the 3/2 all over 3/2 plus c. You can simplify that. That's 2 over 5 times u, but u is the x minus 5, and that's to the 5/2 power, plus 2 times 5 is 10 over 3. Get out the way. Times is some paper on my computer. Got notes for dates for you all's test. X minus 5 is u. That's to the 3/2 power plus c. Use integration by parts. The tabular method. Why? Because that x term will go out. X, its derivative is 1. The derivative of 1 is 0. Alternate the signs. Cosine, you write the first term over there, and then you take its integral. The integral of cosine is sine. The integral of sine is negative cosine x. Let's see if that matches up. That goes there. This goes there, and then the 0 times, yes. So let's see, we have x times sine x. Well, minus times the minus is plus. Cosine x, and then plus 0. And then the constant, right? 0, don't have to worry about adding that, but then by all means we need the constant. Okay, one more. Here we'll use the tabular method. You see that x to the third? Now, anytime we say we're using the tabular method, that is integration by parts, just the shortcut. So right here, x to the third, 3x squared, 6x, 6 and 0, alternate the signs. Write the first term there, sine x. Its integral is negative cosine x. The integral of negative cosine x is negative sine x. The integral of negative sine is negative times the negative. So we get cosine x, and the integral of cosine sine x. These go into alternation. Connect them. This is negative x to the third cosine x. This is positive 3x squared sine x. Let's see if you can get the sequence. So the next term would be negative 6x cosine. The next would be positive 6 sine x. Did I get them? Let's see. I need to match it up here. Take that back. This is negative, positive. This is positive. I didn't get it. This is positive 6x cosine x positive. Don't worry about that. Just we go by this, right? I wasn't going by that. I was just making up some stuff. And I should know that. And we don't use our feelings. And then this is minus 6 sine x plus 0. Minus plus c. Well, I think that'll do it. Thank you.